Okay guys, so we're going to try a slightly new format here and see how it works. I'm not sure how it's going to work, but this is what we're going to try for today. So when you're solving a rational equation, you'll see that there will be a rational expression somewhere in it. There may be multiple rational expressions, which you can see right here. So the first step is to find the least common denominator. Okay, so if we needed to put a denominator for each of them, we could add a 1 to each of that. So you should be able to see that your least common denominator is going to be x. Okay, so you're going to use the least common denominator to clear the fraction. So I'm going to show you how to do that in a moment. And then you're just going to solve as normal. Okay, so let's talk about how to clear the fractions. Okay, so in the first method, in order to clear the fractions, you multiply each term by the least common denominator. So that would look like this. X times x minus 18 times x over x equals 3 times x. Okay, so I multiplied every single term by the common denominator. So look what's going to happen. This is just going to become x squared. Okay, now this one is going to cancel out. So I have minus 18. And then over here I have equals 3x. Okay, now the other option, which is pretty much the same thing, it just looks a little different, is that I just find the least common denominator for everything. So, for this first one, if I needed a least common denominator, it would be x times x over x, because I needed to multiply the top and bottom by x. For the second one, I already had the common denominator. And for the third one, I would have to multiply the top and the bottom by x. And so once I do that, then I can just cross out all the denominators, and I'm left with x squared minus 18 equals 3x. So it's just two different ways to do the same thing. The first way, you're just multiplying each term by x in order to cancel out the denominator. On the second one, if you just find a common denominator, then you can get rid of the common denominators. Okay, so once you get to this point, you're going to solve this just how you would normally solve it. So hopefully you realize all this is just a quadratic equation, right? So to solve a quadratic equation, I'm going to put it in the correct order. Okay, so I'm finding the two things that are going to multiply here. So to make 18, I could have 2 and 9, but that's not going to work. Or 6 and 3, that'll work. So minus 6 plus 3. Now I am solving it, so if I set each part equal to 0, I will have x equals 6, and I will have x equals negative 3. So those are my two answers. Those are the two things I could plug into the original rational expression that would solve it. Alright, let's try another one. Okay, so we have this equation up here that's 10/3 equals 4 over x plus 2. So first we need a least common denominator. Is going to be 3x. Okay, so for the first method, we're going to multiply each term by that to cancel out the denominator. Okay, so let's try what that would look like. So it would be 10 times 3x over 3 equals 4 times 3x over x plus 2 times 3x over 1. Right? Alright, so now let's look what happens. These 3's cancel out, and I'm left with 10x. These x's cancel out, and I'm left with 12. And nothing cancels out there, so I'm left with 6x. Okay, so method 2, I said just find the common denominator, and then you can cancel the denominator. So, for the 10, I have 10/3. So that means I need to multiply both parts by x in order to have my common denominator. Alright, for the 4 over x, I need to multiply both terms by 3. Then, for the 2, I need to actually multiply the numerator and the denominator by 3x. Now I just get rid of that, and I'm left with 10x equals 12 plus 6x. So it doesn't really matter which one of these. It's basically I'm doing the exact same thing. It's just two different ways to do it. Either you can find a common denominator and then get rid of the denominators, or multiply each term by the least common denominator, and that will get rid of the denominators. So 2 different methods to do the same thing. Once I have this, I'm just going to solve it. This one is just a regular linear equation. So I'll go ahead and solve this one. I can subtract 6x. I get 4x equals 12, and x equals 3. So this one only has one answer. The only thing I could plug in is 3. That will make this true. All right. So there's something called extraneous solution. So an extraneous solution, like it says, is a solution of an equation arrived from the original equation that is not a solution. So you solved it and you got an answer, but it's not actually a solution. So you'll see why it's not a solution. So it looks like it is, and you get x equals 5, but then you find out 5 actually can't be the answer. And when you solve a rational equation, it's always possible to get extraneous solutions, so you always need to actually plug them in to think about whether they would work. So in the first 2 examples, nothing was extraneous, they both worked, but you're going to find one that is not going to work next. Okay? Alright. So let's see what this would look like. So I have something like this. I can see that I already have common denominators. So if I have common denominators, I can just go ahead and get rid of them. Alright, so I can see that I'm just going to solve this. So it's just a linear equation. I get 2x equals 4 divided by 2 divided by 2. Okay, so you might say, okay, x equals 2, what's wrong with that? Well, let's plug it back in. That would give me 5 times 2 over 2 minus 2 equals 3 times 2 plus 4 over 2 minus 2. So I get 10 over 0 equals 10 over 0. Although those are true and they're equal to each other, they're undefined. So those aren't real answers or real numbers. So therefore, this problem has no solution. Because the only solution I came up with, which is x equals 2, is not really a solution. So therefore, it has no solution because the only one I do have makes the denominator 0, and, well, I can't do that. Okay. Alright, so last one I'm going to do with you, and then I'll leave you with a couple to try on your own. So this last one, my common denominator, is going to be 2x minus 8. Okay, so for me, I like to just figure out, I already have an x minus 8 on the bottom, so what do I need? I still need a 2. Okay, so 2x minus 5. For this one, there's already a 2 on the bottom, so what do I need to multiply by? X minus 8. And on this one, I already have an x minus 8, so I would need to multiply by the 2. Okay, so if you're kind of confused about that, I'm just kind of shortcutting instead of canceling out denominators. I'm just acknowledging that there's already an x minus 8 here, so I need to multiply the top and bottom by 2. But since I know I'm going to end up just getting rid of the denominators, I'm just multiplying the top by that. So I'm just kind of shortcutting here. Okay, so now I'm going to have to start solving this. So I'm going to distribute. So 4x minus 10 plus x squared minus 8x equals 22. Alright, let me combine like terms. X squared. I have minus 4x minus 10 equals 22. Alright, if I subtract this, I'm going to have minus 32. So now I have a quadratic. Alright, so I'm trying to think of 2 things I can multiply to make 32 that are going to add to 4. So let's see, 16 and 2, that's not going to work. Well, what else multiplies? So how about 8 and 4? 8 and 4 is going to work. So minus 8 plus 4 equals 0. So now I solve these, and I get 8, and I get negative 4. So there's my 2 answers. I think 8 and negative 4. But remember, I'm going to go back up to the top, and I'm going to look. And if I plug 8 in here, what's going to happen? Well, hopefully you said that's an extraneous solution because I'm going to get a denominator of 0. So that means this is not a solution. The only solution to this is x equals negative 4. So be really careful that you look out for extraneous solutions, okay? Okay, so this is going to be the problem that you're going to be doing on your homework at the bottom, so I'm not going to solve this one for you. I will give you the answer tomorrow in class. In case that's too small for you to see it, let me write it a little bigger here. Okay, just to remind you, you need to find the LCD first, so that can help you clear the denominators, and then you're going to go through and solve it. When you get your final answer, check for an extraneous solution. All right, thank you.